Canada is a leading world producer of high-quality honey valued at more than $150 million in 2012. There are approximately 7,000 beekeepers with 704,000 colonies. Honeybee colonies in Alberta, in addition to producing one of the finest honey crops in the world, are commercially used to pollinate large areas of canola. Every spring 80,000 hives are employed for hybrid seed production with an annual value over $350 million and contribute an additional $2.3 billion to the value of agricultural products by pollination services. Since 2006, honeybee mortality has been increasing worldwide. In an alarming trend, Canadian beekeepers reported overwinter losses that averaged 30%. Causes of colony decline are uncertain, but can be attributed to a combination of factors including incidence of pests, pathogens and parasites, improper beekeeping practices, malnutrition, pesticide misuse and exposure that stress and affect the individual and the communal response of the colony.
The Centre for Research and Innovation at Grande Prairie Regional College oversees a new state-of-the-art bee diagnostic laboratory. The National Bee Diagnostic Centre is Canada's first and only lab dedicated to evaluate bee health in the country.
I guess officially it started in November of 2010. We had done a little bit of exploration prior to that. We'd had a few conversations with Agriculture and Agri-Food Canada, and we had an opportunity to meet with Western Economic Diversification and the Rural Alberta Development Fund, and they invited us to put in a proposal, and we did that, and we were successful. So we marked November 2010 as the start. The National Bee Diagnostic Centre, we called it national specifically because there is no Canada-wide effort. Each province has their own level of resources and supports for the bee industry. Some are more robust, some have very little. Too often, dead bees are being sent to the United States for testing because we don't have those facilities in Canada. So, because the National Bee Diagnostic Centre is located at the Beaver Lodge Research Farm, and the reason it's located at the Beaver Lodge Research Farm is because Dr. Steve Purnell's Honeybee Production and Management Research Program is the national research program that Agriculture and Agri-Food Canada supports. So the National Research Program, it made sense for us to put the National Bee Diagnostic Centre adjacent to that and position it as a national initiative. The other reason that we claim that we are the place for this national effort is the college footprint now includes pretty much quite a bit of the northwest of Alberta. Falher is in our college footprint. Falher is the honeybee capital of Canada. The big bee is in Falher. GPRC has the only commercial beekeeping technician program in the country. And we have the research program that Agriculture and Agri-Food Canada operates at Beaver Lodge with Dr. Purnell.
The National Bee Diagnostic Centre is a brand new Level 2 containment laboratory located in the Peace Country, Alberta. It was conceptualized and designed specifically for bee analysis. The building has three different areas. One is the administrative space, a large open lab that includes a microbiology room, and the molecular biology area divided into three rooms. One for the extraction of nucleic acids, a second one for the preparation of reactions, and a third one for the PCR analysis. All rooms are individually pressurized, so the airflow from the molecular biology rooms towards the other areas to avoid any kind of contamination. The NBDC has the capability, the personnel, and the equipment necessary for the accurate, reliable, and timely processing of samples and diagnosis of diseases affecting honeybees from all over Canada.
So here's our storage area. So we have two -80 freezers and two -20 freezers that we store samples. Every time we get samples from beekeepers or in other customers, we store in those -80 freezers, and they can hold up to 10,000 Eppendorf tubes. We have a room dedicated for microbiology. So it's here that we grow bacteria and fungi. So bacteria and fungi that cause disease to honeybees. Also, we have incubators and biosafety cabinets. So it's here that we do antibiotic resistance tests as well. Here we have two incubators. So we're going to incubate bacteria and fungi for a certain temperature, and we have CO2 cylinders so we can regulate the CO2 concentration as well. We have the biosafety cabinet so we can do manipulations, and the samples will be work in a sterile environment so we don't get your samples contaminated or the contamination doesn't get outside. So here we have our microscope station, so where we're going to do the microscopic work, so where we're going to count museum spores and dissect bees, count infestations of varroa mites, or check for tracheal mites. So we have a compound microscope with a nice camera so we can visualize what we're seeing there, and also a dissecting scope. So here we have our general lab. So here we prepare solutions, buffer, media to grow bacteria, fungi. So it's here that we prepare all our solutions, and also where we have the first step of manipulation of samples, the first maceration and dilution or whatever we need to do. Here is the main things in the main lab that we're gonna be doing this kind of process. Here we have the container. That's what we get from the beekeepers, a container full of bees. It's proper label, so we have the right information. Here we have exactly 30 bees that we're gonna be using for this procedure, and we're gonna macerate. So we just transfer to that stomach bag. Then we're gonna use PBS to macerate. So we add the bag. We macerate. We have our molecular diagnostics room, so we have rooms dedicated for molecular diagnostics, molecular technique. So we have the nucleic acid extraction room, PCR prep room, and PCR analysis room. Here we have the nucleic acid extraction. Here we extract DNA and RNA. Over here we have where we're gonna extract DNA, so we're gonna use a spin column method. So we have a manifold to speed up the process. So we're gonna extract DNA over here. RNA extractions will be performed in this machine over here. So we use the magnetic beads method. So we keep separate DNA and RNA extraction. So we use totally different machines. So we can avoid contaminations from both samples. So when we extract DNA and RNA, we measure the concentration, the quality of that extraction using a spectrophotometer. So here we have the spec to do that analysis of DNA. So here we have, in this room, the DNA extraction room and RNA extraction, we have a biosafety cabinet. So we can use that to keep our samples as sterile as possible. So we have the biosafety cabinet, we have a centrifuge that holds different sizes of tubes, so Eppendorf tubes, 15 ml tubes, so we have that capability of centrifuging large volumes and small volumes as well. And also that centrifuge has the capability of keeping the temperature low, so 4 degrees. Here we have the PCR prep, so PCR preparation is here that we're gonna make our master mix for PCR reactions. So we're gonna combine all the reagents, the enzyme, the primers, the buffers we're gonna prepare here. This room, there's no DNA or RNA getting in here. In fact, this room is the room with the highest pressure, so any other contamination from the other rooms will not get inside here. So that's a room dedicated for master mix or PCR reactions. Here's our PCR analysis room. So here's where we run the PCR reactions. So we have two machines, one for conventional PCR, so the endpoint PCR analysis, and we have the real-time PCR. So here where we can visualize the amplification at real time and also run quantitative PCR. So here we have the gel electrophoresis station where we run the gel to separate the bands and the DNA. And here we have the gel electrophoresis. So we have the imager that we check the gel to see if the amplification for a certain pathogen was in the gel or not, or in the sample or not. Here we have an autoclave. So at the end of all procedures, all the biowaste accumulated, we put in a biowaste bag, we autoclave before disposal.
Well, thank you for coming out to the National Bee Diagnostic Centre to visit us. If you have any questions, please feel free to contact us.